So this happens to be, our first session on VSQs. When I say VSQs, I mean very similar questions. So, right away I could tell you this is a real exam question from IIT JEE. And, some of them have come in one or the other way in the real exam in the past. So what we're going to do is, I'm going to take up one particular problem from the real exam. And very similar questions mean, I'm going to populate various possibilities and take up, different types of the same question. When it comes to number of monochloro products, finding structural isomers would not be a challenge. I mean, what we did in isomerism class 11 was, suppose in this compound 3-methyl pentane, if I have to find number of monochloro products, I simply have to identify the positions where, chlorine atoms could go. So if I do it like 1, 2, 3, 2, 1, and 4. I hope you understand. One here or one here would mean both are going to be 1-chloro-3-methyl pentane. Two here would mean it's going to be 2-chloro-3-methyl pentane, whether you put a chlorine here or you put a chlorine here. 3 is again about 3-chloro-3-methyl pentane. So what I'm doing is I'm trying to identify non-equivalent positions. Please respond if there is any element of doubt. I'll be taking all the questions one by one. You can also come up with your answer if you have one. So let's begin with 3-methyl pentane. I would want somebody to respond, and it's going to be question 1, 3-methyl pentane. Now, question 1, 3-methyl pentane. As I already tell you, 1, 2, 3, 2, 1, and I mean number of structural isomers to be 4. Now tell me, what's going to be this count? Number of stereoisomers?
2.
The number of stereoisomers would be, structural, including dextrolevio or cis trans. So this is always going to be a bigger count.
Position 1 or 2 पे stereoisomer होगा.
I mean, a chlorine here, and there's going to be a particularly interesting case. I've told you about this in the past. When you put chlorine here, this carbon becomes chiral. See, this is a little more routine. I'll be drawing these 4 isomers first. So if this is 1, and if this is 2, and if this is 3, and if this is 4, I have drawn the 4 structural isomers. Now, this is simple to identify in the sense, this is certainly going to be chiral here, and this is going to be chiral here. Yes or no?
Yes, sir.
ये थोड़ा सा दिमाग लगाना पड़ता है कि यहाँ पर क्लोरीन लगाने से ये कार्बन chiral हो जाता है, यहाँ पे क्लोरीन लगाने से ये कार्बन chiral हो जाता है, because now you place chlorine here, and previously what used to be 2-ethyl on this carbon is now ethyl and chloroethyl. So these two have become different now. Now this is chloroethyl, this is ethyl, so this has become chiral. And the moment you have chirality here, you'll think about dextro and levio, which means compound 1 or 1-chloro-3-methyl pentane will have 2 forms. Compound 2, and you have chirality on 2 carbon atoms, it obviously is unsymmetrical. So 2 to the power 2 will have 4 forms. Now these two obviously have no element of stereomerism. So 4, 2, 6, 7, 8. Am I being understood? Am I being understood?
Yes.
Yes, sir.
I'll tell you, this is not difficult. This is not difficult. I keep on telling you it's more aptitude than chemistry. But I had to start with question 1, which is a real JEE question. But at the same time, when I tell you it's more aptitude than chemistry, you have to be very focused while attempting this question. Nothing very challenging. And it could be like a scoring opportunity. Integer-based question, you don't have negative there as well. You can score full marks of it. Let's move to question 2. But before that, I want to move to the first page and acknowledge this to be having 4 structural and 8 stereoisomers. Question 2. Question 2. Now, question 2 is obviously kind of getting started. Question 2 is kind of getting started, which is, a 3-carbon propane, but certainly 1 to 1, and I'll be expecting 2 structural isomers, which yet again I'm going to draw like 1 chloropropane and 2 chloropropane. So chalo hana bolo. No element of stereoisomerism. So 1 chloropropane, 2 chloropropane, they're going to be 2 structural isomers, and the number of stereoisomers would remain 2. Third one. Now, third one, I believe, is butane. Now, in butane, the way I've been doing it, 1, 2, 2, 1, there will be 2 structural isomers. But naturally, when I draw 1 chlorobutane and I draw 2 chlorobutane, hey, in 2 chlorobutane, I have this carbon parallel. So here I'll count for dextro and levio, and 2 plus 1, 3 would be the total count of stereoisomers. Yes or no? 2 and 3. 2 and 3. For the second compound, it was 2 and 2. For the third compound, it's 2 and 3. For the second compound, it was 2 and 2. And for the third compound, it's 2 and 3. The fourth one is 2-methylbutane. The fourth one is 2-methylbutane. Let's move on. I hope I'm being understood. The fourth one is 2-methylbutane, and I want your active participation now. You can take a little while. Naturally, structural isomers will come from you. Ritika, go ahead, tell me.
4.
4.
4 sounds good. I think Daksh is also able to hear me loud and clear.
Yes, sir.
Yes, sir.
So
4.
1, 2, 3, 4. I hope this 4 is understood by everyone. And every time I have to draw stereoisomers, I would not take a chance. I would rather draw these 4 isomers.
Total 6 stereo.
Yes, please.
Total 6 आया.
Is 6, the common answer? I believe 6 is right. I am drawing these 4 isomers to begin with. I would want others to respond as well. 1, 2, 3, 4 are naturally 4 different monochlorinated products of 2-methylbutane. And I think Ritika has got the right answer. It's going to be 6 because, see, when you again put chlorine here, I told you this is going to be a particularly important case. When you put chlorine here, this carbon becomes chiral. We generally used to finding chirality on a carbon when you put chlorine. But in this case, you put chlorine here and this becomes chiral. Yes or no? Because it was 2-methyl to begin with. Now it's 1-chloromethyl and, this is methyl. So there's going to be dextropropanoleo. I hope you find this carbon as well. Yet again, hydrogen, methyl, chlorine, and isopropyl. Now this is easy to pick, because generally you put chlorine here and you find 4 different drugs. No stereoisomerism here. So 2, 3, 4, 5, and 6. 4 and 6 is the right answer. 4 and 6 is the right answer. So 2-methylbutane number of isomers is 4, including stereomers is 20 by 6. Yes, we can move on. 4 and 6. 4 and 6 for this one. Now the first one is N-pentane and the sixth one is 2-methylpentane. So you see what I'm up to. I gave you for butane and 2-methylbutane. I'm just now talking about a hard homologue. Pentane and 2-methylpentane.
3 और 4 आया.
3 और 4 आ रहा है पेंटेन का.
हाँ.
So 3 is exactly Again, going by non-equivalent carbon terms. So I think this is understood again by most of you, or all of you rather. Three, simple to understand. 1-chloropentane, 2-chloropentane, 3-chloropentane, and it's certainly going to be a simpler pick. Because when I draw these three, if something goes out of the frame, please let me know. Out of these three, I'll certainly see chirality here only. 4 different groups: chlorine, methyl, hydrogen, and propyl. Here again, I'm going to talk about dextro and levio. So 2, 3, 4. 3 and 4 is the right answer, I believe. 3 and 4 is the right answer, I believe. For pentane, let's talk about 2-methylpentane.
Sir, 5 and 8.
So yet again, yeah, who is that? Please tell me your name.
Sir,
I'm happy
Dutch.
with the response. Dutch is coming up with an answer 5 and 8.
Sir, मेरा भी 5 है बेटा.
So yet again, 1, 1, 2, 3, 4, 5 is something which we have got used to by now. And 5 different chlorinated, monochlorinated structural isomers, where yet again, I would want you to be cautious about this first one. Around this time, you get used to it. This first one, you put chlorine here, and this carbon becomes chiral. It was 2-methyl to begin with, now methyl and chloromethyl. So this is chiral, means this is dextro plus levio. I'm going to talk about carbon 2, which, obviously with 2-methyl group is not going to look chiral. Compound 3, and this is easy to pick. There's going to be chiral here. And compound 4, again, would look chiral. Compound 5, naturally, will have no element of stereoisomerism. But chalo हाँ ना बोलो. So dextro plus levio here. 2, 3, 4, 5, 6, 7, 8. Indeed is the right answer. So 3, 4, 5, 8 is the structural isomers and number of stereoisomers for pentane and 2-methylpentane. We'll want to move on. 3, 4, 5, 8. 3, 4, 5, 8. I want to indicate it here. 3, 4, 5, 8. 7 seems to be a simpler pick. So does 8. So when it comes to structural isomerism, yes. When it comes to structural isomerism, I could very well write it here. 2, 1. There's always going to be an easier pick. 4, yes or no? Let's begin with 7, 8, 9 now. Yes, 7 I think the answer is 2 and 2 only. Yes or no?
Sir, 3 होगा ना?
2 and 3.
2 and 3? Sounds interesting. 1, 1, 1, 1, 2, 2. So 2 structural isomers were naturally, so this compound 1 and this compound 2. The chirality here? चलो हाँ ना बोलो.
हाँ sir.
So 2 and 3, and you're right, 2 and 3. Because here I talk about dextro and levio. You're right. 2 naturally is not chiral because this carbon contains 2-methyl. But one looks chiral now. I'm happy, you kind of connected me in this case. यहाँ पे chlorine लगाने से ये chiral हो जाएगा because now it has a methyl and a chloromethyl, a hydrogen and an isopropyl. So I think I'm being understood. Let's move on. 2 and 3. Next one is cyclobutane ionation. Next one is cyclobutane. But when I write 1, 1, 1, 1, obviously all proteins are equivalent. And there's going to be no stereoisomerism. So, this was maybe only to get you started. And please tell me, what's the popular answer here? What's the common answer here? I'll write 1, 2, 3, 3, and 4.
4, 6.
4, 6, I guess it's that saying 4, 6.
Yes, sir.
Trust me, it's going to be a very interesting case. It's going to be a very interesting case. It's not going to be that straightforward. 4, 6 is certainly not the right answer. So, yet again, I'll keep it simple. One, 2, 3, and 4 is how I want to begin. And let's figure out what are the elements of stereoisomerism here. 4, 6 is what Dutch is suggesting. Do we have an answer from someone else? All right, tell me. Any element of stereoisomerism in compound 1?
No,
I
sir.
don't think so.
No, sir.
Any element of
Yes.
stereoisomerism in
Yes.
question 2?
Yes.
This one? I
Yes.
don't find any element of stereoisomerism here. So remember the rule, to find chirality on a carbon in a ring, the clockwise anti-clockwise journey should be different. So this is anti-clockwise, this is clockwise, and I don't find chirality here. How do you explain chirality here? This is a chiral. This is a chiral. I repeat, I did tell you in the past. Maybe I'll just quickly come to this. You can't call this chiral. This is not chiral. This is a chiral. It's going to be chiral. It's going to be chiral. If the journey clockwise and anti-clockwise is different. So if I have a methyl group here, then this becomes chiral. Remember this?
Yes, sir.
This becomes chiral. This also becomes chiral, by the way. But I'm talking about this particular carbon right now. The clockwise and anti-clockwise journey needs to be different because the 4 different arms, in case of a carbon involved in a ring, are going to be, along with 2 atoms, the 2 fangs of the ring. So, the right and the left or the clockwise anti-clockwise journey needs to be different. I hope I'm being understood. So 2 is a chiral. 2 is a chiral, yes or no?
Yes.
3, now I can say it's chiral. यहाँ पर naturally एक hydrogen है, यहाँ पर naturally एक hydrogen है. So methyl hydrogen, and now the clockwise and anti-clockwise journey is different, both have this carbon and this carbon. And it has no symmetry. And if it has no symmetry, it's simple, you can simply go with 2 to the power n. So 3 is going to exist in 4 forms. Tell me for compound 4, do you have any chiral carbon?
No, sir.
You don't have any chiral carbon because again you talk about this. The clockwise anti-clockwise journey is seen, and you talk about this. Yet again, the clockwise anti-clockwise journey is seen. But what I realize is, a chlorine here and a methyl here at 1,3 positions. Don't you think you can have cis and trans geometry here? So it's about diastereomerism. The 2 hydrogen could be cis or the 2 hydrogen could be trans? Yes or no?
Yes, sir.
Yes, sir.
Methyl and chlorine could be syn or anti. So here I'll count 2. And this is what I told you, it's going to be a particularly, a nice problem where 4, 2, 6, 7, and 8. 4 and 8 is going to be the right answer. But chalo, Hana bolo.
Sir.
Yet again, not very challenging. At the same time, would call for the very basic elementary understanding of chirality in a ring. And obviously, I don't find any chiral carbon here. The very concept of, the clockwise anti-clockwise journey being same is about, just having a kind of plane of symmetry. So this was a chiral, this was chiral. And, I keep on adding. If I have two methyl here and both of them are like cis, yet again, this will become a chiral. This carbon will become a chiral. Again, because, I can have a plane of symmetry here. I can speak in this language, which is easy to understand. The clockwise anti-clockwise journey again becomes the same. But what is for courses? Generally for finding stereoisomerism, I would recommend you draw the structural isomers and then go by your practical wisdom. So 8, 1 and 1, 9, 4 and 8. 8, 1 and 1, 9, 4 and 8. 8, 1 and 1. This was 2 and 3. Now this was a nice problem to solve eventually. 10 and 11, 10 and 11. So 10 is 1, 3, 5 trimethyl cyclohexane all being cis, and 11 is methyl cyclohexane. Let's talk about 10 now. 10 and tell me how many structural isomers to begin with. That's a simple question.
3.
1, 2, 3, 2, 1, 3, 2, 1. Is how I go about, telling you about 3 non-equivalent positions. Wherever I've written 1 are 3 equivalent positions, in which are 1 degree carbon. Everywhere I've written 2 are equivalent positions, 3 degree carbon. And everywhere I've written 3 are equivalent 2 degree carbon. And let's keep it simple again. Let's draw the 3 isomers. CH2Cl. This is chlorine. And again, you have a chlorine here. So I think I'm able to write for the 3 spectral isomers right away. But you know, how about number of stereoisomers?
Till 12 होगा.
No. You're kind of over speculating. See, when it's all the 3 methyl now cis to each other, there is a symmetry. जब तीनों cis है ना, तो symmetry है. मतलब you always have a pair of symmetry, either this way or this way. So don't expect any optical isomers here. इसमें तो खैर कोई स्कोप नहीं है, 1 तो 1 ही रहेगा. यहाँ पर कहीं पर भी ऑप्टिकल आइसोमरिज्म हम लोग नहीं स्कोप नहीं रखेंगे, बिकॉज when the 3 are cis, ये क्लोरीन के लिए यहाँ पर there is a pair of symmetry. You can put a mirror like here, and the left and right would be mirror images. In this case, you can put a mirror here. So this is going to be a plane of symmetry here. This is going to be a plane of symmetry here. This is going to be a plane of symmetry here. Don't expect any optically active compound, no chiral carbon. And when it's no chiral carbon, I only think about the possibility that this chlorine out here with respect to the other two could be either above or below. I don't know whether to call it cis or trans, but I'll call it dark stereomers. Because this chlorine could be above or below. This is cis to begin with, but certainly when a free radical addition is happening, this will get deoriented. So this chlorine could be above or below, and no optical activity here. And yet again, this chlorine, with respect to these 3, could be above or below. So, I'll talk about 2 dark stereomers here. Not go into the, debate of which is cis and trans, or whether the term cis and trans is relevant here or not. But, 2 possibilities, chlorine above or below. floor above and below, 2 to 4, 1, 5. Please let me know if you can, clear it out. But yet again, the answer is 3 and 5, wherein 2 and 3 are only explore dark stereomalism. Symmetrical isomerism is also a safe word to say, which will have 2 GI. Will have 2 GI. 3 and 5. 3 and 5. 11 is again going to be a little challenging. I guess we can move on. बच्चे लोग खाना बोलो.
हाँ सर.
11, please go ahead.
11 का 5 और 12 है.
5 or 12 is spot on. 5 and 12 is spot on. And this is such an ideal end to this particular session where, in the last problem, I would be very delighted if you come up with the exact explanation. Now, this is 1, 2, 3, 4, 5, and I keep on doing this, 4 and 3. So 5 structured isomerism, is obvious. Can you tell me how 12? Although, I'll again want to draw the 5 first. So you have chlorine here, and you have chlorine here, and you have chlorine here, and chlorine here, and chlorine here. Please go ahead and tell me how 12.
1 और 2 में कोई कायरल कार्बन नहीं है, तो दोनों में कोई स्टीरियो आइसोमर नहीं होगा. और 3 में
कोई कायरल कार्बन भी नहीं है और कोई जीआई भी नहीं हो सकता है.
3 में 2 कायरल कार्बन है, तो 4 स्टीरियो आइसोमर होगा.
2 कायरल कार्बन है और कोई सिमेट्री का चांस नहीं है, तो 2 to the power 2, which is compound 3 can exist in 4 different forms.
कंपाउंड 4 में भी सेम ऐसे ही होगा.
Compound 4 में भी same. Sounds good. Naturally, 2 कायरल कार्बन है, so 2 to the power 2, it will be 4 here.
And compound 5 सिस और ट्रांस होगा.
Excellent. यहाँ पर सिस और ट्रांस होगा. यहाँ पर geometrical isomerism होगा, because yet again the journey clockwise anti-clockwise is same with respect to this carbon and this carbon, so there is no chirality here. Very nice. This is exactly what I wanted to hear. 4, 4, 8 to 10 to 12. 12 is the right answer, and I'll kind of complete this set of questions. We had 3, 5 and 5, 12 as the number of structural and stereoisomers respectively for the last 2 cases. I would have wanted to carry on with a few more cases had there been a little more population attendance in the class today. I think either people are still stuck up with the board preparations, or maybe you're not expecting me to be taking class just early in the morning. But I want to check the schedule of boards, and I'll certainly share a few more problem sheets of this kind. So I have a few problem sheets prepared. मैं एक तो भेज ही चुका हूँ, VSQ2 बोल करके. उसमें simple problems हैं to begin with, and again, there's no point saying something simple or difficult. It's about being able to arrive at the right answer every time, and it's going to be organic to begin with, and then sooner than later, organic and physical chemistry. Anything we want to talk about right now? Otherwise, I'm going to end this session right now, and hope to see you at the next opportunity. All good? ठीक है बच्चे लोग, मिलते हैं फिर. स्टे हैप्पी, स्टे हेल्दी. इसके बाद का जो प्रॉब्लम शीट है सिंपल सा ही है, उसको भी अटेंड करके उसका एक पिक मेरे को भेज दो. that keeps me moving, and as I told you, hope to see you at the next opportunity. मिलते हैं बच्चे लोग. Bye bye. Take care.
Bye.